I need a Jamb 2026 student to tell me why many students feed this question on the board. I visited a CBT center just in the concluded 2025 Jamb examination, and many students saw this question in their computer. But then I noticed that when they gave me the answer they picked, it was very, very different and wrong. Okay, many of them chose the wrong answer. None of them, only like a few percent, chose the right answer in this question. But let us see the reason why they might have failed it. Okay, the question is in physics on electricity, and the question is, in which of the electrical circuits below does the lighted bulb glow brightest? That's the easy question, and they are giving four different electrical circuits. First is first, you watching this video, I want to see if you also feel it, if you are seated in that JAMB examination, which was just 2025. Okay, now attempt the problem and drop your answer to the comment section. Is it option A, option B, option D, or option C? Okay, drop it in the comment section. I'll respond to you, letting you know how well you did. Also, I'll be giving a bonus mark to those persons that give me the reason for the answer just before I explain it in this video. Okay, so do that, drop it in the comment section. I'm guessing you guys have done that by now. Let us now see the right answer to this question. Okay, now if you notice, all of these are cells. Okay, we are having EMFs connected in series and parallel across these various diagrams. Okay, they want us to see the one that will glow the brightest. Now there are two ways. If there are resistors, we are going to pick the one with the least resistance. Okay, that is what will make the bulb glow brightest. Remember, resistance is what now a stop to a flow of current. Okay, now the lesser the force that is stopping the current from moving, okay, the more the light bulb will glow. Okay, another way is to increase the current or increase the EMF or potential difference. Now the more the potential difference, okay, that is flowing through the circuits, the brighter the bulb is expected to glow. Okay, now let's look at these various options. Okay, now since there are no resistors, we can ignore that first concept. Let's talk about EMFs in series and parallel. Now for this one's in series, for this one's in series. Now first is first, we can eliminate two options. How are we going to do that? For EMFs that we're assuming each of the EMFs are having the same voltage, that's what you should take note. We're assuming they are having the same voltage. Now first thing you should take note of, if an EMF is in parallel, it is always equal. For example, if this one is 5 volts, this one is 5 volts, the bulb is going to receive 5 volts, not 5 plus 5. Why? These two guys are in parallel. Are you seeing it? It's going to receive what now? Just 5 volts. Okay, so if these two combine, they're having two EMF, but it's still going to receive 5 volts. Let's compare it to these ones that are having two EMF each, but are in series. Okay, this one is having two EMF, this one is having two EMF, they're in series. We know it's going to be combined 5 plus 5. That's what now 10, Abby. So we're going to ignore these two. This one is already out of it. Why? Because the 5 volts will remain what now? Constant. Option D is out. Look at option C. Option C, the two EMF are also in what now? In parallel, right? Since these two guys are in parallel, if they combine, they will also produce what now? The same volts. So this one is 5 volts, for example. This one is 5 volts, for example. Once they combine, they will also produce what now? 5 volts, which means the bulb is also going to receive 5 volts, and this one is out of it. You see the trick with eliminating the wrong option. We're left with option A and option B. Now, let's look at option B. You now come to your senses that the shorter lines represent negative potential, the longer lines represent positive. Negative, positive. Okay, now let's check the direction of flow of current for this particular question. Okay, current tends to move from a higher potential difference to a lower potential difference, right? So for this EMF, current will move from plus to what now? So minus, right? The current will flow in this direction for this EMF. Why for this one? Plus to minus. It will flow in this direction, right? Now, if these two guys are having the same potential difference, they will cancel each other because current wants to flow here and current wants to flow here. So the bulb will never light up. But if for a case that they are different, for example, this one is 6 volts and this one is 5 volts, okay, the current will move in the what now? This one is 5 volts, okay, so this one will force the current to move in this direction. Are you getting me? The current will force to move in this direction. But in the end, you're not going to have 6 minus 5, that's 1 volt. 1 volt is very low compared to these ones that are even 5. Okay, now let's look at this one. We're having minus here for the short term line, we're having plus here, we're having minus here, we're having plus here. So plus to minus going to move in this direction, plus to minus going to move in this direction. So in total, if this one is 5 volts, this one is 5 volts, 5 plus 5, that's 10. 10 volts going to the bulb will produce what now? The brightest bulb. Okay, so obviously option A is the correct answer. It doesn't end here. I will always tell you guys, there's always more to learn. Not just in physics, but in other subject combinations. That includes the arts, social sciences, commercials. Okay, now if you are a science student, this one is a very easy question. We have other kind of question on YouTube following the various subject combinations that you might be offering. Okay, now this one is very, very easy. In our next video, I'll talk about another one. If you got the question correctly with the actual answer you did not guess, kudos to you. I'm glad you guys are preparing well for the 2026 examination. Now, if you have any more questions, feel free to drop it in the comment section. I'll respond to you as usual, especially on physics. Okay, this one I just taught. You can drop it in the particular videos comment section. I'll respond to it. Now, if you wish to join our classes, online classes where we teach not just physics, chemistry, math, biology, but making sure we complete the syllabus for the JAMB exam before the examination, all you simply have to do is click on the link on my bio to reach out to me on WhatsApp. Okay, now if it doesn't work, click on open in browser. Okay, from there you can click on the link to my DM. Okay, text me on WhatsApp, then you want to be registered for the classes. We also have a free WhatsApp group chat. All you simply have to do is once you click on the link, click on open browser. Okay, and then click on open WhatsApp channel. Okay, you can just join it directly. We'll post likely examination questions for free on the WhatsApp channel. Okay, we also give updates regarding the JAMB examination, so you don't miss out on any of the important updates coming from JAMB directly. If you have any more questions, feel free to drop it in the comment section. Don't forget to like this video, share with your friends, and text me on WhatsApp if you're unable to click on the link on my bio. Text me on WhatsApp via this phone number on the screen, or give me a direct message on TikTok. Don't forget to like this video, share with your friends, and follow for more.